We are Group 7 Sydney, and this is our project, a smart real estate CRM database that integrates property management with sustainability and IoT features. Today, we will explain the background, so our conceptual models, present our relational database, and demonstrate SQL queries that solve real business problems. Real estate agency in Australia often use scattered tools to manage property, clients, and documents, but buyers today demands more. They want to know about energy rating, green certification, and even smart devices in a property. Core Logic report shows these features are influencing property values. Our project builds a CRM database that unifies all of this into one reliable system. Our scope was clear: build a system that manages all core CRM data, properties, clients, agents, listing, transaction, and extend it with sustainability, feature, and IoT tracking. This not only improves operation but also aligns with how the Australian property market is evolving.
Uh, Next is the data requirement and the conceptual design. And for our project, we begin by gathering the data requirements from the real estate industry context. We identify the key entities that are essential for business operation like property, client, agent, listing, viewing, transaction, payment, and document. When we consider the relationship between them, for example, one agent can manage many listings, one client attempt multiple viewing, and one property can appear in different listing over time. To strengthen our design, we also included advanced concepts like specialization, generalization, and associative entity. This conceptual framework ensures that our database not only captures core business need but is also scalable and flexible for future requirement. Next is AAR diagram. So this is our AAR model. We can see how property is generalized into residential and commercial, and transaction is generalized into scale and rental. We model weak and associative entities as well. For example, payment is fully dependent on transaction, and entities like listing, viewing, and property device resolve many-to-many relationship. We also applied semantic modeling techniques such as specialization, aggregation, and normalization up to 3NF. This demonstrates our design goes beyond the basic and capture real-world business complexities. Let's move to the UML class diagram. So the UML class diagram complements the ER diagram by showing the same concept in an object-oriented way. Each class represents a table with attributes, primary key and foreign key clearly defined. For example, one transaction must be linked to exactly one property and one client, but it can be associated with multiple payments. Similarly, property can have multiple smart devices and documents. The YAML notation helps developer by showing multiplicities and inheritance, making the structure easy to implement in code and ensuring consistency between the conceptual and relational model. For next slide, we welcome our next team member, Surat.
We have implemented our conceptual model EER into relation schema, where strong entities become base table, subtype becomes separate tables linked by a foreign key, associates associatives like listing, viewing became their own tables, having the foreign key and primary key linked to their base tables. Payment was modeled as a weak entity and tied to the transactions. This ensures the design is third form of normalizations and avoid duplications and maintain the referential integrity. For this, uh, we have implemented the SQLite on the web browser. We have created the following tables for our project. And while creating the tables, we have ensures that the constraints are defined. For example, energy ratings, client emails are unique, and each foreign keys enforce integrity across the tables. This means our system is robust and prevent bad data integrity. And we have these are the table we have implemented, and we have inserted certain amount of data to the following tables like listing, viewing, transactions, and we have performed some of the queries like queries to find the okay, sorry. These are some simple query that we have performed to show the active property that's on the cells, and that has energy rating from 80 to 100. And we have another query that displays the client ID that have the emails, which email is not null. Also, we perform another query where we join two tables showing the listing of the property and the agents whose listing property is on sales and it's currently active. And we perform another query with the subquery inside where we shows the average sales uh, performed by the agent.
Let's move to the Srijan.
Okay.
Oh, just
So in summary, our system unifies CRM function, sustainability tracking, and IoT integration into a single relational database. It ensures integrity, reflects real American markets, and delivers insight for agents, clients, and management. So in assessment 4, we will take this further for advanced analytics. Thank you.